Alright, so today we're going to be doing lesson 7.1 notes, which is simplifying rational expressions. So we're going to talk about what a rational expression is. We're also going to be dealing with eventually rational equations. We're going to be dealing with a lot of rational things in this section. So this topic actually comes up a lot in college algebra courses and whatnot. You'll see this through different math classes and calculus and all of these things. You have to be able to simplify rational expressions. So we're going to introduce you to that today. So let's talk about what a rational expression is. So when we say a rational expression, what I mean is it's just a ratio of two polynomial expressions. So basically a fraction with a polynomial in the numerator and the denominator. Okay? And the reason that we call these rational expressions is because they have restrictions. Because x can't be everything, because we can't have 0 in the denominator. So these problems have restrictions. So this is the three-step process to simplifying rational expressions. The first step is to factor the numerator and denominator. You're always going to factor the numerator and denominator. Then you're going to identify any restrictions which would make your denominator 0. So basically you're going to be setting the denominator equal to 0 and finding what values would make the denominator 0, as in what variable values. So like what x, what y, whatever variable we're using. Now, this is very important. Write a star, whatever you got to do here. It is important to do step 2 before step 3. So you cannot cancel out common factors until you have identified the restrictions. If you do this backwards, you're not going to have your correct restrictions, okay? Very important. Restrictions come before canceling, always. Any questions about those steps? All right, let's go ahead and look at an example together. So simplify each rational expression. So the first thing you want to do in these problems is factor the numerator and denominator as much as possible, okay? So what can I factor out of the numerator here? 6. Don't they both have they're both divisible by 6, both terms, right? So 6 times k minus 6. Everybody see what I did there? I just factored out a 6. And then we have this over k minus 6. Now before we simplify or cancel anything out, we need to set our denominator equal to 0 to find our restriction.
I have a question. So factoring, do you only do it like if you were to factor out only the numerator or like only the denominator? Like you can't factor them out both?
You have to factor both. This denominator just happened to not be anything to factor.
Yeah.
But yes, if it came up where you had to factor, which it will, you're going to have to factor the numerator and denominator. This one just happened to only have a numerator that could be factored. So then we set our denominator equal to 0. And we get k equal to 6. So what that means is your restriction is that k cannot be 6. So it's important we find that restriction. Okay, whatever you find that the answer is to setting the denominator equal to 0 is what your denominator, your value for your variable cannot be. Everybody see that? So once you've done that, you can now simplify this. So what can I cancel out in both the numerator and denominator here? Good, the k minus 6 cancels. And the simplified version of my polynomial is 6. So that's simplified. K can't be 6, meaning oftentimes in the end, you're going to end up with like 6k, or the variables with still in the answer. That just means that there's a restriction on what k can be. But here, we don't have anything to plug into, so it's not too applicable. But basically, the rule is you have to find the restriction before you simplify. It'll make more sense in the next example because the variable will be left in our answer. Does anybody have any other questions on this? Okay. So now we're going to move into another problem that we'll see the variable still remains. So in this question, the first thing we need to do is factor the numerator. Anybody remember how to factor these? These are where we have to take the square root ones. Anybody remember what that factors into? Okay, so let's just refresh our memory. So let's say we have p squared And we're going to put in that placeholder term, 0p minus 49. So 0p is a placeholder term, okay? Now that I've done that, I should now be able to factor this like any other trinomial. So factors of negative 49 that add up to 0. Any ideas? Good. Positive 7 and negative 7. So anytime you have something squared minus something that's a perfect square, the two factors are going to be whatever the square root of that number is, but the positive and negative version of it. But you can always do the placeholder term method if you forget that. So you put in the 0p. And then this is all over 7 minus p, right? And this can't be factored. Well, it can be, but it's not necessarily easy to identify what we can do with this. So from here we have to, before we cancel anything out or simplify, we need to find our restriction. So we need to set our denominator equal to 0. So we set this equal to 0 and we solve for p. And we see that our restriction is p cannot be 7. So that's your restriction. So now our goal is to then see if we can simplify this rational expression. Now, is there anything that we can cancel out here? Almost, because the problem is they're not in the same order, right? But let's say we rearrange the denominator like this. So we rearranged it to negative p plus 7, which is the same thing as 7 minus p, right? Now, what can I factor out of this denominator that will make it look like one of these numerators? Can't factor out a 7, but we can factor out a negative 1. So we're going to take the new denominator, we just flipped it around, and we're going to factor out a negative 1. So all that's going to do is change the signs of each term. So that's going to be p minus 7. So everybody see what I did there? I just factored out a negative 1. Just changes the sign of both terms. Now that we've done that, what can we cancel out? Good. The p minus 7 now cancels out. And I'm ultimately left with p plus 7 over negative 1. Now, can I simplify this at all? We could divide each term by negative 1, right? So what's p divided by negative 1? Good. And then what's 7 divided by negative 1? Negative 7. So this is our final answer. So this is just a little bit of a factoring trick that comes up sometimes, is when the order is backwards, if it helps you to think about it this way, when you have something that's the same in both the numerator and denominator, but the order is backwards, you can simply multiply it by a negative 1, and then you can cancel it out. So basically you have to factor out that negative 1 for it to work. So do I have any questions so far on this? Okay, let's move on then. So, moving on to example 3, what do you see right off the bat we can factor out of the numerator? 2. Good, we can factor out a 2. So we're going to factor out a 2. Oh wait, that's not right. Getting ahead of myself. There we go. 3n squared plus 4n plus 1. So I just factored out a 2. So now that I factored out a 2, does anybody remember how to finish factoring this? We have to use the AC method. Do you guys remember the AC method? You have to multiply your A by your C. 3 point. We remember the unit, the lesson and everything?
No, I said you multiply it 3 to
Oh, I thought you were saying that we did learn that in 3.1. I was like, wow, that's impressive. I don't remember which
no,
lesson.
I have
You're right. We multiply the 3 by the 1, which makes this a 3, right? So I guess if we want to write in that extra step, not to confuse you guys, because you might get confused if I do this. To write in that extra step, it's going to become n squared plus 4n plus 3. And then we have 2, and then we can factor it. So this is going to factor into n, and then what are factors of 3 that add up to positive 4? 3 and 1. And then what's the last step required in the AC method?
You have to divide the numbers.
Good, you have to divide both of these by your A. And if it divides, you're just going to divide it, which 3 divided by 3 is just 1. And then what do you do if it doesn't divide? Good, you bring it back in front of the n. Just like that. So in the green, what we have here is our simplified numerator, okay, our factored numerator. So now we have to deal with our denominator. So let's go ahead and deal with our denominator first, before we deal with anything else. So to factor this denominator, what do you notice we can factor out of this denominator? Good. So we're going to factor out a 2, which leaves me with n squared minus 1. Now, if you have a term squared, it's not fully simplified. So when that happens, you can put in a placeholder. If you don't have a regular n term, you can put in a placeholder 0n term. Or, if it's x, whatever the variable is, you can put in that placeholder term. And then once you've done that, you can now factor it like we always do. So what is a factor of negative 1 that adds up to, what are 2 factors of negative 1 that add up to 0? What times what? Negative 1 and positive 1 would multiply to give me negative 1, but would add up to 0. So those would be our 2 factors.
Do you have to do the AC method when you factor? Like, are there certain situations where you have to use it?
Yes. The only way you can factor this otherwise would be to use the quadratic formula. So I guess if you really wanted to use the quadratic formula, it's going to take you like a lot of space, but that would be the other option. So then from here, we would now just rewrite it as a fraction. So I have my numerator in the green, and I have my denominator, which was in the pink. So are we ready to start canceling things?
No, you have to do the,
Yeah.
you have to find the restriction.
You have to fill on this line before you simplify anything. It's a common mistake. I've made it myself. I just jump in, I'm like, start and cancel. No. You have to simplify this first. You have to find the restrictions first. So basically you're going to set your denominator equal to 0. Okay, so we take our denominator, because we can't have 0, we're going to find out what's going to make it 0. Now this looks like a quadratic, right, that we would set equal to 0. How do we find our solutions here? We'd set each one equal to 0. Remember the zero product property states that if we have the product of things equal to 0, then they must be 0 if any of the terms are 0. So you would set each one of those equal to 0. What happens with the first one? Doesn't work. Reject it. The next one comes out to be, yep, you're right, negative 1 and positive 1. So those are our restrictions for our denominator. Those are values that your denominator, or your variable can't be because they make your denominator 0 at some stage. So the answer here would be, we can't have negative 1, we can't have positive 1. Now, I want to mention this just because I know these tests like to get fancy with you, ACT, SAT. Another way they could have worded this is they could say n cannot be plus or minus 1. So that's the same thing, but just another way of saying that. Because they could also get like fancy with you and say, what's the restriction? They could have said it like this. So just kind of want to mention that. That's another way they could have written it. So now that we've done all that, we found our restrictions. Now we're ready to see if we can cancel anything out. So what do you guys think? Can we cancel anything out here? Good. The n plus 1 and the 2's can cancel, which ultimately leave us with 3n plus 1 over n minus 1. and this would be our simplified form. So what do you guys think? Easy, hard? It's a lot of work. It is.
There's like no room.
I know. So yeah, on these you're going to want to write a little small. Like you can fit it. Like I tried it. I did my cube, but it is a little tight. I know. It's tight. So does anybody have any questions about any of these ones? I'll zoom out so you can see it. Any questions on this one? Now, once you get good at this, I'm exaggerating, showing every step and every little detail. Let's move on. So this is multiplying rational expressions containing only monomials. So there are two ways to do these problems, and I'm going to show you one of them doing both ways so you can see it. Okay? So the first thing you want to do, now you can either find your restrictions before you multiply them or after you multiply them, but it needs to be done before you cancel anything out. That's the main idea. You can't cancel anything until you find your restrictions. So I personally just like to find my restrictions right off the bat so I don't forget. So I'm going to see what x can't be and what y can't be, because they would make my denominator 0. So this one's actually pretty easy to just look at and see. What would x have to be here that would make this denominator 0? Anything multiplied by what is 0? 0. So x can't be 0. And if y was 0, this would also make the whole denominator 0. So x and y can't be 0. So if you ever just have a variable that's not added or subtracted by anything, it's just going to be 0 for that variable that can't be. See how if we plugged in 0, that would make the whole denominator 0 for each one of those, which wouldn't work. So once we've identified our restrictions, we can move on to actually solving this. So to solve this, we have a few different options, and I'm going to show you the first option first. First option is to simplify each of these fractions separately, then multiply. So let's do that method first. So we'll do this one in pink. What's 6 divided by 2? Good. What's x squared divided by x squared? 1. So it just goes away. It's just 1. So 3 times 1 is 1. And then, anybody remember how to divide different... Good, you guys remember things I teach you. Okay, so 3 minus 2 is 1. So it's just y to the first power. And then, we're going to do the same thing with the second one. Does 18 go into 10? No, but can we reduce that fraction? They're both divisible by what? 2, which makes this 5 ninths, right? And then what about the x third? It's not divided by anything, so it just...
Where did you get the 5 ninths?
That's just reducing 10 eighteenths by dividing it by top and bottom by 2. So it's just x to the third, and then it's going to be y to the second, 4 minus 2. So once you have this, you can then just multiply these two together. So when you multiply a number and a fraction, you just multiply the numerator in that number. So you get 15 over your denominator, which is 9. And then x has nothing to be multiplied by, so it's just x to the third. And it's going to be y to the what? Third. Because remember, you add exponents, and this is an implied exponent of 1. So does everybody see how we got that so far? Now, are we done simplifying this? We can do one more thing. Anybody know what?
Reduce the fraction.
Good, we can reduce the fraction by dividing the numerator and denominator by 3. So that's going to give me 5 thirds, and that's x to the third, y to the third. And those are both on your numerator, okay? So you can write it as on your numerator, or you can write it as 5 thirds times whatever those numbers are. Same thing.
We have to do over 3.
Yep, because 15 ninths reduces to 5 thirds. So any questions about method 1? Now we're going to practice method 2. So method 2 is to multiply first and then simplify. So I'm going to do this one in blue. So you're going to multiply across first. What's 6 times 10?
60.
Good. What's x squared times x to the third? X to the fifth. You add exponents when you multiply. And then it's going to be y to the 7th over 2 times 18 is 36. X squared, because there's no other x to multiply by, and then y to the 4th. Now once you do that, you're going to simplify this. So 60 and 36 are both divisible by 12. So we can reduce that by dividing the numerator and denominator by 12, which comes out to be 5/3. X to the 5th divided by x to the 2nd is x to the
Third.
good. And then y to the 7th divided by y to the 4th is y to the 3rd. So see how we end up with the same answer regardless of which method we choose. So which one do you think is easier? The second one? So, yeah, they're both. So I'm going to just say that there's certain times when the second method is easier and there's certain times where the first method is easier. It really just depends on the problem. Times where the second method is harder is when you have like a trinomial in the denominator and a binomial. You're not going to want to multiply those, so you want to simplify first. So like I said, just assess it based on the problem to decide which way you're going to do it. So does anybody have any questions on example 4? All right, are we ready to move on to example 5? All right, example 5, we'll do this one the multiplication across method, just because. So we're going to multiply across first, but before we do that, we're going to identify our restrictions. Now I do want to mention that you can multiply them together first and then find the restrictions. That's okay, you just can't cancel anything. Does that make sense? You can multiply them, but you just can't cancel anything. So what can A not be here? Yeah, it can't be 0, and B can't be 0. The only time that you're going to have something different than that is if you have like A minus 3, A plus 3, or A plus 4, or something like that, is when that's going to be different than 0. If you just have the variable itself, it's just going to be 0. So now we're going to multiply across. So what's 4 times 5? Good. A to the? Good. B to the? Good. All over 15 times 12. Yeah, 180 is good. And then A to the? Good. B to the 10th. Once you have this, like I said, if you did this stage first, you could still have found the restrictions right here. This is the step where you have to, point of no return. So now we're going to start reducing stuff. So 180 is actually divisible by 20. So this actually comes out to be 1/9 reduced. Times, what's a to the 5th divided by a to the 5th? 1. So that just cancels out. The reason I specify that it's 1 is because if you just have a to the 5th divided by a to the 5th left, you have to make sure you put that 1 there. But if it's with anything else times 1 is just itself, so you don't have to worry about it. But I just noticed a common mistake is people forget that this is 1. And then what is 8 minus 10? -2. So I have b to the -2. How can I make that b exponent positive? Bring it down to the denominator. Because when you do the method of, if you knew right off the bat to keep it in the denominator, that's fine. But technically, you do always the numerator exponent minus the denominator exponent, and whatever you get with that division has to go in the numerator. If you're familiar with that process and you just know that the bigger exponent stays down, that's fine too. So this would be your simplified version. So this is why finding the restrictions right now is so important, because we would never have found that restriction on the a at the end because there's no a left to even restrict. So does anybody have any questions on example 5?
So, if a cancels out, or if a equals 1, why wouldn't you just put the variable for this a?
What?
If a equals 1, why didn't you just put a?
A doesn't equal 1. A to the 5th divided by a to the 5th is 1.
So,
anything divided by itself is always 1. The reason I mention that is because if you have a problem,
Oh, okay, no, I get it now, it's just one.
it's just 1, so anything times 1 is just 1, so you don't have to worry about it.
I thought it'd be like just A.
No. It would be just A if it were a to the 5th divided by a to the 4th.
Okay.
Does that make more sense?
Mhm.
Okay. Are you guys ready to move on to the next one? Okay, let's move on. So the next one is going to be multiplying rational expressions containing binomials and trinomials. So these problems are just going to be the same procedures, but the factoring will just be a little bit more lengthy, that's all. So the first thing you can do in these problems is just factor each of these fractions separately, and then we'll find our restrictions. So let's factor these as much as possible. So what can I factor out of the numerator in example 6? We can factor out a 4, but we can also factor out a 4. Good. So we're going to factor out as much as we can. That's going to leave me with 4x times x minus 1. Now, as for the denominator, what can I factor out here?
2.
Good. I factor out a 2, and that leaves me with x squared plus 2x minus 3. And then we're not finished factoring this because now we're going to have to factor this into 2 binomials, right? So we're looking for factors of -3 that add up to a +2. Good. +3 and -1. And now we have our factored form of our original fraction. Now we're going to move on to doing the same thing with this fraction here. So we're just going to factor it. And remember, this is a 1 in front of this. So what are factors of -6 that add up to a +1? Good. And then what can we do to factor the denominator of this fraction? We can factor out a 4x. You could factor out a 2, but you want to factor out the biggest thing you can factor out. And that's going to leave me with 4x times x plus 2. So now I'm going to bring this down to line it up with the other one because we are going to have to multiply these together eventually. But before we do that, before we can multiply these together or cancel, before we can cancel anything out, we need to do what first? Good, we need to find our restrictions. So like I said, once you get good at this, you can save yourself this step and you don't need to actually set each of these equal to 0. But we're still learning, so we're going to set each of these products in the denominators equal to 0. So 2 equals 0, x plus 3 equals 0, excuse me, x minus 1 equals 0, 4x equals 0, and x plus 2 is equal to 0. So these are all of our restrictions. Now this one just gets rejected, and then I'm just going to solve these. So that's going to be can't be -3. X can't be +1, x can't be 0, and x can't be -1. So I just solved all those one-step equations to get those results. So once you find your restrictions, you're going to move on to simplifying your fractions. So the first thing you want to do is see if you can cancel out anything within the individual fractions. So can we cancel out anything over here in the pink? The x minus 1s. And then also, 4 divided by 2 is actually just 2. So this is replaced with a 2. Because 4 divided by 2 is just 2.
Doesn't the 4 have an x on it?
Multiplication you can cancel. If it were addition, you can. So then from here, there's nothing I cancel out here, so I'm just going to multiply everything together. So when I say that, all I'm going to do is list everything on this numerator on one big fraction. So that's 2x, because remember we just replaced this 4 with 2, times x plus 3 times x minus 2, all over These two canceled. All I have left over here is the x plus 3. And then all I have over here is the 4x times x plus 2. So you just basically write everything that's left on one big fraction. You guys see it? Okay. So then once you do that, you're now just going to cancel what we can cancel. So what can we cancel out in the big fraction? The x plus 3. We can also cancel out these x's, right? And then that leaves me with, when I do that, 2 times x minus 2 over 4 times x plus 2. Are we done simplifying? No, we can reduce this fraction to 1 over 2, which is just x minus 2 over 2 times x plus 2. And that would be our fully simplified form. So there are times when you might cancel out what you think is fully canceled, and at the end you see something else needs to be canceled, and that's fine. You can do it in multiple steps. There's nothing wrong with that. And that's ultimately our answer. So, do we have any questions about this so far? Okay. Are you guys ready for the next question? All right. Let's move on to the next one. So what we're going to do here is we're going to simplify this as much as we can, okay? So up here, what can I factor out of both of these terms? Good. 5v. So when I factor out a 5v, that's going to leave me with 2 minus v. So I just factored out a 5v. And then over on the denominator, we're going to have to factor this like a trinomial. So what are some factors of 18 that add up to a negative 11? Good, negative 9 and negative 2, right? Times, let's do the next one. So what are some factors of negative 9 that add up to negative 8? Good, negative 9 and positive 1. And you can't do anything with the 15b right now. So once you get to this stage, we now want to find our restrictions, so we're going to set all of the denominator products equal to 0. So this is going to be 9. b can't be 9, set it equal to 0, set it equal to 0, and set it equal to 0. So I solve this, I get v can't be 9, I get v can't be 2, and I get v can't be 0. When you divide both sides by 15, you get 0. So I can fill this in. Do you have a question? Yeah, we do the restriction for the whole thing, so you do it for both of the fractions. Negative 1? Oh, you don't worry about the top, just the bottoms. Because it just can't be the denominator that's 0. It's okay if the numerator is 0. Yes, so always just the denominators. So, any questions about how I found the restrictions? Alright, so now that we found our restrictions, I'm just going to erase this step so we have a little room here. So now the next thing you want to do is cancel within the fractions first. So remember that rule I showed you? You can cancel these out, but you have to add in a what? Not a regular one, but a negative 1. So this is just going to become negative now that you did that. And that's the faster way to do it. On the last question, I showed you the long explanation way of why that works. But once you're comfortable enough with it, you can just make the numerator negative and cancel those out if they're just backwards terms. They have to just be backwards. And then over here, is there anything to cancel out? No. So once we've done that, we're just going to rewrite everything as one big fraction. So that's going to be negative 5v times v minus 9 times v plus 1 all over v minus 9 times 15v. So what can I cancel out now? V minus 9. I can also cancel out the v's, which leaves me with negative 5 v plus 1 over 15. And is that fully reduced? No, I can reduce that to 1/3, right? So that's going to be negative v plus 1 over 3. Now, in this case, where it's the negative v plus 1, if the answer were multiple choice, they could have also distributed that negative 1 out. So the answer, another equivalent version of this answer would be negative v minus 1 over 3. Okay? They could have distributed that negative 1 out. So just be aware of equivalent expressions, okay? All right, so all we have left now is the extra credit section. So what we're going to do right now is we're going to take like a 5-minute break. And then what we're going to do from there is I'll show you how to do one of those problems. It's actually very easy based on what we've already done. And then I will put up the video with the rest of the questions done. If you're interested in it, you can watch it. Yes. Yeah, go ahead. So this is going to be x squared plus 5x plus 4 over x squared plus x minus 12 times 2x squared minus 6 over x squared minus 1. Now you just have a problem that you just did earlier, and you just proceed the same exact way. So see how it's really the same thing you just learned. So now we just do everything else the exact same.
Oh, wait, hold on. You change what?
Keep the first fraction, change your division sign to a multiplication sign, and flip your second fraction. And now you proceed just as you would with any of the other problems.
That's not that bad.
No, it's not bad at all, right?
Then the restriction is just still the same. Like
Yep.
just-
You find the restriction the same way, so we're going to have to factor everything here. So we'll just go through and do the whole thing. My thing's just lagging on me. So that's going to be become x plus 4 times x plus 1 all over x plus 4 times x minus 3 times 2x times x minus 3 over x plus 1 times x minus 1. So I just factored everything. Once you do that, you set your denominators equal to 0 to find your restrictions. Okay? So you can do it by just looking at it at this point. X cannot be negative 4. X cannot be 3. X cannot be 1. And x cannot be negative 1. Everybody see how I got the restrictions? Now you just simplify by first simplifying each fraction individually. So cancel what can be canceled. Looks like we only have one thing that we can cancel. And then multiply across. So just rewrite it as one big fraction. And now we just cancel what we can cancel. So the x plus 1s can cancel, and the x minus 3s can cancel, which ultimately leaves me with 2x over x minus 1.
That was not hard.
No, it's not. And it's basically...
Okay.
So we do our first one.
So is it okay if I question?
Yeah, go ahead. and then we flip the second one. And then factor everything. Can factor out a 3 here. And then your restriction, set your denominator equal to 0. So that's x can't be -6, x can't be 2, x can't be, well, x can't be -6, we already did. So then we can simplify. And that's it.